we go. Thank you for your patience. Let's get started with this example on examining the relationship between between the distance and the price of these airline flights. All right, so the first thing I took the time to do was to type it in. Look at that, it's already gone. Let's turn the calculator back on. Make sure before you do this, if you're watching this video and you're trying to type the numbers in yourself, make sure you take a moment to do diagnostic on. So that way when you do your linear regression, you have all of the information that you will need. All right, we've decided in class, I'll write it here, we've decided that distance explains price. All right, you don't have to write that. That's just really for my brain. I know what is going to be my x and what's going to be my y. All right, so I'm going to make the scatter plot by going to second stat plot. Let's turn it on. And because I put my x values in list 1 and my y values in list 2, I can just go straight into doing graph and then zoom 9. All right, so here's the scatter plot. So let's call on someone that's going to be famous now. All right, let's call on, Thomas wants to be the person. Let me get near you, Thomas. All right, Thomas, how would you describe this association?
It's positive, linear, and moderately strong.
You're going to go with moderately strong. Yeah. Personally, I know I put it in the Kahoot. You weren't here for the Kahoot. I don't really like doing moderately strong. I just say weak, moderate, or strong. So you can write moderately strong. Go for it, man. I'm just going to say moderate. All right, now, a few of us did not get full credit on doing this on the Chapter 7 quiz because we forgot the context part. You got to make sure you do the context part. So Thomas said great words, but then he needs to say between and list the two variables. Exactly. All right, so I'm going to write there is I think I heard positive, linear, moderate association between distance and price. Now, one thing that I mentioned in the Corolla example, if you've already watched that video, is that right now we're still in Chapter 7, if you will, right? This idea of making a scatter plot, looking at the association. So far, still Chapter 7. I want to move into the new stuff in Chapter 8, which is actually running and using the linear regression model. All right, so you have to ask yourself this question. You must do this if you're going to go to the next step, which is, do you think that the shape of this, I don't want to say shape, the form of this is linear? Yes. It is, right? You said it in your sentence, but if you're just kind of forgetting, always go back to your sentence. We said this was linear. If you say it's linear, then it is okay to go to the next step, which is to actually make the model. All right, so let's make the model. We're going to get a ton of stuff, including our correlation coefficient. Letter R is going to be there. All right, you've already done this. I just haven't actually taken the time to teach you what the other letters mean. All right, so go to Stat. We're going to go to Calculate. All right, go to number 8, which is the linear regression A plus BX. If you've already started the links from IXL for Chapter 8, you'll notice that their links are having you put it in the other way, where it's the slope-intercept form. All right, it doesn't matter. I'm just going to show you this is the way that the AP exam will always give it to you, with the intercept going first. Okay, so this idea of A plus BX, that's why we choose this one. All right, so hit enter. You've used this before, so this should be familiar. The new thing is, and if you watch my video on the Corolla, is I'm actually going to show you where you can store the regression equation. So if you scroll down here where it says store regression equation, you don't have to do this, right? But we're going to do some questions here. Maybe not actually on this one, but if like we want to use the model and we want to input a certain distance, like say we pick a city that's not up here, right? H-Town's not up here, right? See how Houston's not here? So let's say we find out how far away Houston is, all right? We could input that mileage and the model will spit out the expected price, all right? And we can do that very simply if we store it. So I'm going to hit vars. So hit vars, right? VRS, just vars here. Go over to y-vars. Go over to y-vars. Hit enter on function. All right, I'm going to tell it to put it in the y1 equation or function. All right, so I'm going to put y1, hit enter, and you should see this now pop up. So we're going to store the regression equation in y subscript 1. Okay? We can practice that more. It's not really that necessary, but if you want to, you can. The reason I like it, let me calculate first. All right? And I'll come back to this screen. Let's show you just for a second. Right? Now look at the graph. Do you see what happens now in the graph with the scatter plot? Sick. Right? Do you see what that is? That is the linear regression line. That's the model. All right? So essentially, you see these squares that are above and the squares are below, right? It's telling us, right, this is what we expect to happen. So you can see this price is more than we thought. This price is less than we thought, right? We'll talk later on what that is. All right? You would need to do another equation. This is just the y. Like if I go to y equals, right, it put the equation here in y sub 1. All right? Say it again. What? How did I do that? I hit vars and went over to y-vars. All right, so let's actually write down. Let's write down this model. All right. Do you guys want to write down R first? Because I think I asked for letter R. It was 0.694. So go back to what you said, Thomas. You said moderately strong, or I'm going to say moderate. Does that match now when you do letter R, 0.694?
Yes.
It does, right? So that is a moderate in terms of strength. So I don't need to go back and change any words. Okay? So let's write the equation for the linear model. My key thing I teach students every year when I do this is that when you write the equation, don't use X and Y. Okay? Just go ahead and use the words of the variables. All right? What is our Y variable? Fair. I'm going to use price because, we don't live in the 1920s. All right, so price. All right, now whenever you do this, make sure your Y variable gets a hat. All right, it's sunny out there. That's a joke. Wasn't a good joke. The reason you put the hat on, besides to protect you from the sun, is because this means predicted. Predicted. We're going to predict prices. Right? I mentioned like if I plugged in the mileage to fly to Houston, it would spit out a price. Is that the actual price? Probably not. Right? That's what the model is predicting it would cost. All right? Equals. The first thing you write down is your A. This is our y-intercept. The letter that's not next to the x is the y-intercept, right? The one that's next to the x from your days in algebra is the slope. All right, so my y-intercept is 177.21. Plus my slope, which is 0.08, and then times what is my x variable? Distance. Excellent. So I'm going to pause here. Any questions so far? That's the first time we've done that. You've seen that before, right, Raul? It's been in the calculator. We just haven't actually used it yet. 0.08, I rounded my slope, which is letter B. Because the reason I rounded to that is because this is talking about price, so money. So I'm talking about 0.08, so it would be cents, right? 8 cents. 0.0. Times the distance. Yeah, you got it. Looks good. Now, let's do 4 and 5. I can guarantee you'll have to do this on the AP exam. And actually, if you guys remember your SAT, you'll have to do this on the SAT as well. All right? Yes, coming up soon. So interpret the slope. Let me tell you what the slope means with zero context. Okay, this is no context. The slope means is that I increase my x unit by 1. So if I increase my x by 1 unit, then the y value should change by the slope. All right, so let's think about it in this context. What is my x? Distance. So what would be an increase of 1 in distance? 1, does it say 1? Doesn't say. Let's assume 1, what do you think for the unit? Mile, probably 1 mile, right? So each mile, right, that we have to fly, what am I expecting to happen to the price? to go up by 8 cents. You could say $0.08. That's fine, right? But I'm going to say 8 cents. So I'm going to write for each additional mile, I'm going to say flown, I expect to pay 8 cents. Everybody okay with that? Right? Remember, when we take this quiz next week on chapter 8, you will have to do this on your own. All right, let's do 5, the y-intercept. All right, so no context. The y-intercept is when x is 0, the y-intercept is y. Okay? So in this case, what is 0 for my x? What's 0 for distance? What would be 0 distance here? Well, no, what would that mean? Like 0 what? 0 miles. So have we flown anywhere? No. So if we're going to fly nowhere, it's going to cost us $177.21. Does that make any sense? A 0-mile flight will cost us $177.21. Now, I agree that doesn't make sense, but let's think about what that could be. Maybe Eduardo's got some thoughts.
If you say it like this, you could say the initial cost of the flight without
Factoring in
the
distance that you gotta go.
would initially be 177.
I agree. I think you could say this doesn't make sense, but on the other side, I think it could make sense, right? Because what we got to pay for? What do you got to pay for? The seat, okay, like the food. Depends on when you fly. The people's salaries flying the plane and serving you. Service. If they don't own those planes, they're probably paying to rent the movies you watch. Really get into the heart of the flight. Okay. The blankets, the vomit bags in the back, right? Oh, man, all the good stuff. That's right, the flotation device, so you can save your life. The oxygen masks, put on first, and then your children. That's what they tell you. That's what they tell you. You can't help a child if you're unconscious. Go ahead. Fair enough, right? And this is many, many years old. So, all right. What? Yeah, if you have children, you're sitting with children, they have to tell you by law. They have to tell the parents, and you have to look and nod that you understand you're going to put on your mask first before helping your children.
See, they should explain that. You should start there, because I was like, that's kind of crazy.
Well, no, the reason is, you know the reason, right? Because if you're unconscious, your kid's going to be like, hey, what's up? I need help. But super calm about it. Okay. Is it appropriate to use this model? Remember, we just wrote it down, right? I just wrote it right here, right? I wrote this model, okay? We have to see if it's appropriate to use this going forward. Like I mentioned the Houston example, okay? So here's what you have to do. You have to check. I'm going to put it on the side here, and then I'll write what I'm doing. I have to check the residuals plot. Okay? Now, this is a word that if you haven't watched anything with Chapter 8, if you haven't listened to my lecture, if you haven't read the book, if you haven't done anything, you may not have heard this word residuals yet, right? You need to know it. It will be on the AP exam. A residual, and I'll put it onto the side here. So residual, and you can look at the back of my card here has residual formula, equals observed minus predicted. Okay, so the moment that you hit calc 8, right, number 8, and you did linear regression, the computer, right, the calculator, is immediately making that model. It immediately made this line, all right? And then also immediately, this is amazing, it calculated if it plugged in these x values into this distance and spit out this new price, right, and then compare it to the original price, right, that's it right here, it calculated those residuals instantaneously. I know, amazing, right? Gosh, so glad we don't do that by hand, okay? So now what you have to do is you have to check the residuals plot to see if it's okay to use this model. And when we check the residuals plot, I'm going to put it right here. I'm hoping for nothing. And when I mean nothing, right, I'm going to see dots or squares in this case. It's not that I'm not going to see anything. I'm just hoping for no pattern, right? I'm hoping for no curve pattern. I'll show you what it's called when it's a fan pattern. I'm hoping for nothing interesting. Remember the word we use? I drew it up there, right? Remember the word we use when you see nothing in a scatter plot? A cloud. Very good. You're hoping for a cloud. Okay? So you ready? All right, so let's do this. Turn it back on. Mine's turned off, so make sure you turn yours on. All right, I want you to go to second. Oh, wait, no. Yes. Second stat plot. So second stat plot. Go back to the first one. Now, if you haven't done the linear regression, if you skip that part with me and you go to do this, it won't be there. All right? So you've got to do the linear regression to get the residuals. All right? So now, instead of doing my list 1 and list 2, because it can't calculate them if you don't do the regression equation. That's what I'm saying. So now, when I do my residuals plot, leave the x alone. All right? So remember all those distances were in x? Leave them there. Don't touch it. But now, our y value, I'm going to scroll down here. All right? And I want you to hit second stat. See where my cursor is? See how it's on the y? All right? Hit second stat. Second stat. And then if you look here at number 7, it says resid, which stands for residuals. Make that your y. All right, so now when I graph it and do zoom 9, it's going to show me the residuals plot. And what am I hoping for? Nothing, right? A cloud, no pattern. Let's hope and pray. Here we go. Oh, you know what? I should have done this first. Let me take that line out. My bad. Hold on. Go to y equals. Click y equals. If you did the storing, you need to do this if you want to get that to go away. Hit y equals. Do you see the equal sign here? If you scroll to the left to be on that equal sign and you hit enter and see how it's now when I go away, it's not like shaded or darker. Now when I graph it, it won't graph that. All right, so that's why you can like kind of turn off those equations. Let me show the residuals and I'll come help you. All right, so graph and then zoom 9. And this is what you should see for the residuals plot.
Oh my gosh.
Was it frozen? Okay. Right, so sometimes you just got to let it go. Okay, so now, one person. Okay, do you guys see the line here?
Yes.
That's 0. So if you've got a square that's right on that line, that means the actual price and the predicted price of that flight are the same. So you get a residual of 0. So when you see the squares that are above the line, they have positive residuals. All right, that means that the equation is predicting the cost to be more than it actually is. And if you have negative residuals, right, it's the other way, right, where it's actually costing the customer more than the model thinks it should be. All right, so like in our case, right, we would want to have a positive residual, right, because that means the line is thinking, or the model is thinking it costs more than it actually is. All right, so if you're paying these prices, you're overpaying according to this model. All right, anyway, we'll get into that later. So, what do you see? No. We're hoping to see nothing. Do you see anything? Or is it a cloud? It looks like a cloud. I would say that there's more squares here. Why are there more squares over here? Because most of these cities are, somewhere between like 200 and 600 miles away. But you've got a couple that are way out here, like Seattle, Salt Lake City, right? They're much farther away. Okay, so that's why here, all right, you have a few that are that way. I think this is nothing. I think this is a cloud. So here's what you write. The residuals plot shows, bless you, no pattern. So it is appropriate to use this model.
You're always going to say whether it is or isn't.
Correct. Yes, and so if I check the residuals plot and I see a pattern, let me show you some examples of a pattern. So let's see it, say it looked like this. Okay, what would be that pattern? That's a curve, right? So that'd be a pattern. That'd be no good. All right, what about, this is one of my patterns for called a fan. Do you see how it kind of like starts together and then like fans out? So that's another one that you might see in the residuals plot. They're like, whoa, 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 that's something going on. Okay? So if you see nothing, if you see a cloud, then it's okay. You can use, it's appropriate to use the model. And if it's not that, then it's not appropriate. So you can use it, but you should be pretty cautious about it, about using it. All right, but I would say don't use it. All right, let's do r squared, and then we'll kind of finish this problem. We got lots more iterations of stuff to do in the next coming days. But r squared, all right, you notice if you go back to your calc page for the linear regression, it was right here, right above r. And it says r squared is 0.482. So r squared. All right, now here's how you're going to be asked to describe r squared when you do this on the AP exam. Okay? I try to tell students that r squared is like how good your model is. All right? You guys learned from the very first model we ever did that all models are wrong. Okay? But this r squared can be something you look at to determine if I really want to use this or not. And so the closer that is to 100% or 1, the stronger or better it is. Now, that's not always true, but you can see this isn't even approaching 50%. Or it is approaching 50%. We're not even getting close to 100%. So here's how you write it, all right, with no context. R squared measures the change in your y, okay, the change in your y, described by the change in your x. All right, so let me write it for you. So 48, and I always use a percentage, 48.2% of the change in a flight's price can be explained by the distance.
Sorry, you said the r squared measures the change in your y.
That's explained by the change in your x.
That explains.
Yes. Or described. Well, either word is fine. So this is the sentence that I always write, Joseph. So, yeah, you're good. 48.2% of the change in a flight's price can be explained by the distance. So that means there's a lot of stuff out there that could determine the price of a flight that's not based on just the mileage. So what do you guys think? What do you think are some other factors that the airlines take into account when they price flights for you to purchase? That has nothing to do with how far away you're flying. Interesting. So yeah, if you choose a ticket that has a nicer seat, absolutely. That's it? Anything else?
The real plan.
You again with the food, right? Okay. Fair enough. Say it again. What airline? Okay. What if they're all the same airline?
The quality of the airplane, the kind of airplane model.
Oh, interesting. So if you're a bigger airplane, smaller airplane?
Gas.
Luggage, how much luggage you're taking? Okay. Maintenance on the airplane? I mean, yeah, you could. If the airline you're flying has very old planes, they require more maintenance. It's going to cost the consumer more money.
What about gas prices?
Yeah, gas prices. Yeah, for sure. Absolutely. I think we're missing kind of a crucial one. A clue? It's hard to give a clue without giving the answer. Let me end my recording.